after doing all this long division, I'm going to show you a shortcut that is called synthetic division, which works most of the time for what we want to do. It will not work if our divisor is something that's really big, like some of those on your homework last night were, let's see here, they were like x squared plus 2x plus 5, and you had to divide that into something. So we're not going to be doing anything like that. Okay, so here's the setup. First things first, start off with your divisor. In this case, it's x minus 5, and set it equal to 0. So in this case, we'll have to add 5 to both sides, right? And we're going to use this number for a synthetic division. So I'm going to write that in front, and I'm going to do something that kind of looks like an upside down long division. So here we have this that goes over, right? For synthetic division, you actually do the line, but you go under. Okay? And the numbers that we're going to put here are not going to have any variables. We're going to put the same coefficients. So like here we have a 1, an 8, and a -3. So we're going to put just those coefficients, 1, 8, and -3. And you know, on here we put these horizontal lines several times. We're going to do one of those immediately. And just like we drop down like these -3s, we have to drop down several times when we're doing long division. We actually drop down the very first number every single time. So there's a lot of similar things there. The long division, it's just maybe in a different place. And this is the setup to start the problem. Okay, without doing any calculations, it's just the beginning how to set it up. So it's nice having these on the first 3 problems on your paper there side by side so you can kind of see the similarities. On the back side, you're going to use only synthetic division. So only in the first 3 do you have to do the long version. Then after you do the first 3 synthetic, you'll know how to do it for everything on the back. You don't have to do the synthetic on the back. So let's practice on number 2, just doing the setup, and then we'll come back. So we have x plus 1. Set that equal to 0. So in this case, we're going to use -1. And this will have a much greater purpose later on. Right now, I'm just going to show you the technical part on how to do it. And later on, you're going to find out, you know, why you're doing it, what you use it for, and how it relates to the graph of a polynomial and so on. So today, just the technical part. So what numbers should we put here? Right, well, we got 1, we got the 3, 3, and 1. Okay. I'm going to bring down just the first right there. All right, do it one more time on number 3. So now we have 2x minus 1 equals 0. So that means 2x equals 1. And divide both sides. So x is 1/2. So we'll use 1/2. Now, what number should I use here? All right, 4, -3, 7, and 2? No. 4, 0, -3, 7, and 2. So same as long division. Don't forget, if you're missing a variable, use a 0. So some rules are the same as long division. There we go. Okay, so that's just the setup. Okay, not too bad. And the goal here is that we want to get the same answer with this method as we do here. All of these variables, all this stuff floating around, we're going to somehow get the same answer by doing this. And so they have to match at the very end. So let's go back to number 1. I'll show you the process. So we are going to multiply these two together and then write the answer here. So 5 times 1 is 5. I'm going to write it directly underneath the 8. So it has like a column format similar to long division. And then go ahead and add them up. So 8 plus 5 is 13. And then repeat the process one more time, just with 5 times 13. And then write the answer below the negative 3. So we get 65. And then 65 minus 3 is 62. And now if you haven't already seen something going on here, look at the answer we got in the long division. X plus 13, remainder 62. Look what we got here. 1x plus 13, remainder 62. So you can see how much work we did here just to get this answer, and look what we did in just this amount of time. Gave you the same exact thing. You just have to know that this 1 and this 13 stands for 1x plus 13, and that the last number here is always the remainder. So the last is always going to be the remainder. So that could be a 0, and that means the remainder is 0. There's no remainder. And then from here, we can count to the left from the remainder and know, okay, this is the constant. This is the linear term, to the first power. If there's more numbers, we know that's the second power and third power. But it's pretty powerful because we can get the same answer quite a bit faster. Now, a reminder, this only works when you have a simple divisor, though. We have like x minus 5. If this was something more complicated, we wouldn't be able to use this. That's why we haven't done this up to now. But we have not written the answer down. The answer is in the same exact format as long division. So we can get this answer, the same thing, by doing this. Just take your divisor, right? Use your answer here and decode this, knowing that this 1 means 1x. The 13 is the constant term, and the last number is the remainder. And these, your answers for long division and synthetic division, are going to actually match. Okay. So let's do a couple more just to get the hang of it. And then, like I said, on the back, you'll just do only synthetic division. Just like yesterday, the checks are optional. You don't need to check every single one, but just make sure you know how to do a check. So during a quiz or a test, you have the ability to do that if needed. All right, so let's go to number 2. So if you already have the long division finished, like we do here, we can already see that our answer should be 1, 2, 1 with a remainder 0. And you can see that, well, we just brought down the 1, so this one and this one are the same. And if we just carry this out, so we have negative 1 times 1 is negative 1. 3 minus 1 is 2. That 2 coincides with this 2. Negative 1 times 2 is negative 2. 3 minus 2 is 1. So it matches this one. And by no surprise, negative 1 times 1 is negative 1. The remainder comes out to be 0, just like we got here. We went from all of this to just this little bit. Now, I'll give you a little preview. When you get a remainder of 0, it means that value is an x-intercept. So we've kind of forgot this because this was last December before break and everything. But we were worried and concerned about having these x-intercepts to know, where does the polynomial cross like this. So what we just did, when you get a remainder of 0, we just determined that negative 1 was an x-intercept. So that's how this is going to be useful to us later on. Because you start solving like 4th degree, 5th degree polynomials, it gets kind of difficult to figure out where these x-intercepts are just by factoring. So we have this synthetic division to quickly go through and determine if it's a x-intercept or not. So let's do the last one. Same idea. So we have 1/2, half of 4 is 2. 0 plus 2 is 2. Half of 2 is 1. Negative 3 plus 1 is negative 2. Half of negative 2 is negative 1. 7 minus 1 is 6. Half of 3 is, half of 6 is 3. And we get a remainder 5. Okay? So how's that look? Is that good? What do you think? Anybody pick up on anything interesting here, though? Let's go back here. Remember, these should match, right? We should be getting the same answer like we did here. So we got 1, 2, 1 on long division. I got 1, 2, 1 on synthetic. When I say, is this a good answer, that's what you're really doing. So is this a good answer? No, I got 4, 2, negative 2, 6. I should be having this, right? 2, negative 1, 3. So looks like the remainder is good, 5. But what happened here? Anybody see a connection? Very good eye. So we divided by 2 here. On our divisor, we have to divide our dividend by 2 as well. Divide each of those by 2, and then you end up with 2, 1, negative 1, and 3. Now you can see 2, right? The numbers are much better. So if you end up dividing up in this step by something, dividing your divisor by 2, we have to divide our dividend or a quotient here by 2 as well. Just to make it the same thing on both sides type of thing. Yes. Yeah, you have a very good eye. So that's the next part. These have to match. Do they match? So that means what? Conclusion? There's a mistake somewhere. So this is what I really want to focus on for you guys right now today, is that you're still going to have mistakes with negatives. So if you come up with 2 different answers, figure out what the mistake is going to be the real skill here. It's seeing a whole completed problem that looks really well done, but then picking it apart and finding the one little negative that was missed. So on average, or usually, the synthetic division will be correct because it's shorter, it's faster. So can we go over to long division and spot the mistake? That's supposed to be plus? Okay, which makes this plus. So we have to change this one too, which means this has to become positive. Positive. So now you can see from here, we have 2, 1, negative 1, 3, 2, 1, negative 1, 3. All right? So yeah, but you have to have this eye that if you get 2 different answers for the same problem, you can't just say, oh, it looks great, I did something. You know, you got to keep persevering until you find out, well, what is the mistake. Okay? Sure. One more thing, reminder, I did not divide the remainder by 2. So the remainder is always going to be the same, but the quotient here you have to divide by whatever you divided up here. So these will match. Okay. Okay. So let's look at the number 4 on the back. And go ahead and try it on your own, or go ahead and try it with someone next to you and see if you guys get the same thing, or just work with each other as you go. Hey, is this what you guys got? Yes? All right. So let me have your attention for a moment. Ready? Okay, so the last number is always the remainder. If you want to start writing your answer this way from right to left, that would probably work. So we know it's negative 56, 31. The next will be x, and the next one will be the x squared. So you can work from right to left to write your answer, and then you'll just have x minus 2 here, right? Does that look good? What is it? X plus 2. Yeah, don't forget, this is not the sign. This is always the same, x plus 2. So small things can always get in the way. Just be very careful when you're checking your answer, okay? So one more. Let's go to 6 because it has the fraction part. So do 3x plus 1 equals 0, which means 3x is negative 1, which means x is negative 1/3. So using negative 1/3 do synthetic division. So we get 6, negative 25. What goes next? 0, very good. 0, for the 0x squared that is not here. And then go to negative 3 and 5. All right, take a moment to do that. See how it goes? Okay, so bring down the 6. We're going to do 1/3 times 6, or 6 divided by 3 with a negative. So we got negative 2 gives us negative 27. Negative 27 divided by 3 is 9 with a negative. So we get 9. 9 divided by negative 3 would be negative 3. So we get negative 6. And then negative 6 divided by negative 3 would be 2. So we get 7. Okay? That look good? So our answer would be what? Three x plus 1, right? Okay. Now, watch up here. Watch up here. Okay. So how can I tell by looking at just these two and multiplying them that I have the wrong answer? These two, if you multiply, should equal the first term of our answer. First term of our answer is 6x to the 4th. If I multiply these two, I get 18x to the 4th. So automatically I know this is wrong. So what did I leave out? Divide by 3. But you can see, you can check just the first term and know it's wrong without doing the entire check that takes forever. Just by checking the first term, you'll know pretty fast that you forgot something. So really, I need to divide each one of these by 3. So we end up with 2, negative 9, 3, negative 2. And then when you check these two, 3x times 2x to the 3rd does equal the 6x to the 4th. So you know you're on the right track. So please continue to check, but not maybe that thorough check where you multiply everything out. Okay, so that should give you enough to finish up the back. Let you guys work with the little remaining time that we have.